Hi guys, so this is gonna be a demo video to walk you through our assignment number 2. So I have a very similar assignment that I'm gonna do, and you'll have a different data set to work with in R. All right, so last time with our assignment number 1, you were working with a smaller data set. This time I'm giving you a much larger data set to use, right? So the first thing that I want you to do, as you did before, is hit pound, right? Remember when we hit pound in R, we can type whatever. It's telling R, hey, I'm not doing a command, I just want to type some notes, right? So the first thing I want you to do is put your name, and then do another pound and tell me the assignment, right? The assignment is R assignment number 2, right? And then hit a couple lines down, and then the first thing we need to do is get your working directory like before, and then we need to set the working directory. So I'm just going to copy and paste this. So right now by default R wants me to work in my documents, but I as I mentioned before, like to work on my desktop. So I change that last part in the file path, and that will put it on my desktop. Right, so if I hit enter, nothing is good, right? So now, now basically I told R, hey, I'm working on my desktop. That's the files, that's the data that I want to work with, right? So now I need to tell R specifically what file. So I'm just going to say data, and we can hit this symbol, right? Or again, we can do equals, and then we need to do the read.csv format, right? And remember, my data file has to be saved in a CSV format, right? Which I've already provided the data in that format. So I already downloaded the file on my desktop, right? So it's important that your file is already saved there, right? So my file is already saved in my desktop, and I titled it actgpa.csv, and it's all caps besides the CSV, right? Put that in quotes, in parentheses, hit enter. And again, nothing is good, right? R is not screaming at me, which means I didn't make an error. And then the next command you have to do is we have to attach our data, right? So now I'm telling R, I want to use that data set right now, right? Because remember, one functionality in R is you can work with multiple data sets at once, right? So you have to attach the data. That way R knows which one you're working with at that moment, right? So then now what we can do is we can do names of my data, and this will tell me what variables I have, right? So in the file I have ACT and GPA, right? So if I open up the file really quick, so you can see here's the file, and those are the titles of my variables, right? ACT and GPA, right? So that's all that's pulling, right? So we'll close that, don't need that. All right, so now we're ready to start working in R, right? So it says, what is the first thing that we should check before running a regression model, right? So the first thing that we should check is the scatter plot, right? So we should first check the scatter plot to be sure that a linear model makes sense for our data before proceeding with the regression linear model. Whoops, I have a typo there. Right, so you remember in the text that was described, right? And I also talked about it if you're in my class in the lecture videos. So we first need to see a scatter plot and see, does it make sense? Does my data look to be linear? If the answer is no, then it doesn't make sense to continue on with the regression linear model, right? So we should check that. So now it says insert a scatter plot from R below, right? So remember, to get a scatter plot, the command is plot. And then what goes first is your independent variable, right, along the x-axis. So here we would want ACT, and then comma, and then GPA. So my my y variable, right? I gave you what the x and y variable is above in the directions. right? So if you didn't read that already, the scenario is we have a director of admissions of a small college who selected 120 students at random from the new freshman class in a study to determine whether a student's grade point average, GPA, at the end of the freshman year can be predicted from ACT test scores, right, labeled ACT. So we're using ACT as the X variable and GPA as the Y variable, right? So, and also to point out that this assignment does measure these two college graduate competencies in math, right? So that's actually 8 out of the 20 points is being able to make connections from math to the world applications, and then also the technology component, right? So using R as my technology piece is a part of this, right? So make sure you read that first and understand the data, right? I should have mentioned that first, but I wrote this assignment in this data set, so I'm very familiar. So I was already familiar with that, but as you who hasn't seen this before, you should have read over that. So back to the scatter plot, right? The command in R is plot, and then I have my X variable, comma, my Y variable, and then I can do comma, and I can use the main command, and you do main with equals, and then inside quotes I can add a title, right? So maybe do ACT versus freshman GPA as a title, right? And I can hit enter, and now I have my scatter plot, right? So I'm going to hit this minimize button so that way I can see this a little better. I'm going to right click on it, copy. You can do copy as a meta file or a bitmap. It doesn't make a difference for us. And then I can just paste this in, right? And it pastes a very large scatter plot, so I'm going to minimize that, make it look a little better. We can also center it, right? I can go up here and hit center, make it look nice, right? So it's not too small where I can still read that okay, right? And that way the question and the answer also fit on the same page, right? That looks a lot nicer, a lot neater. Right? So now we're ready for the next question, right? So question 3 says, what is the predictor variable and what is the response variable, right? So the predictor variable here is the X variable, right? We're using that to predict the response variable, right? The response variable is the Y, right? So we would say the predictor variable is ACT and the response variable is GPA, right? So now it's asking us to use R to calculate the regression line, right? So I'm just going to minimize this scatter plot and open this my R window back up, right? My command window. So we want to calculate the regression line. So I'm going to call this model, and we use the LM command, right? So model equals LM, and then you're first going to put in the Y variable, so GPA, and then you do tilde, and then the X variable, ACT, right? Close that, hit enter, and then since we named it, that's why it's not doing anything. So I need to go summary of my model, right? So by hitting summary of my model, we want to zero in on this part here, right, where it says estimate, right? We have intercept ACT. So this number is my intercept, right? This is my slope. So these two values are what we want to pay attention to, right? So now we want to insert the equation. So I would like you to use equation editor in Word to do this, right? So to do this, you go to insert, and then underneath symbols you're going to see equation, right? So now we can type in an equation, right? And a shortcut to do this, so I use equation editor a lot, right? So you can hold down Alt and then hit equals, and that will also pop up, right? If you have a Windows, I'm not sure. The command might be different for a Mac, right? So then now, what I would do is click on this accent button, and then if you notice this symbol here says hat, this is typically used in the response variable, right? So if we click that, and then I can type GPA underneath of that, right? So what we're saying is this is the mean GPA, right? And then we can hit equals, and then we would have my slope, right, which is 0.0383, right? And this is times ACT, and then plus my intercept, which is 2.11405, right? So I went ahead and just used the 5 decimals that R provides, but you could certainly round that if you'd like, right? So if you wanted to come in and round that to the nearest tenth, right, that would be okay with me, right? So there would be your equation rounded to the nearest tenth, right? So then now you're asked, what is the slope of the regression line, right? So the slope of the regression line is 0.04, right? And that is by rounding to the nearest tenth. So then now we need to interpret the slope in context, right? So we could say the let's see. So we could say the average freshman GPA is changing by 0.04 grade points per point on the ACT. Right, this would be a pretty good interpretation, right? So I gave you a generic sentence that you can use, and this works pretty well most of the time. So you can see inside these like greater than, less than symbols, that's where you're just filling in that information, right? So the output, so you're saying what the output variable is changing by your slope, and then what's your y units per your x units, right? So you're just filling in those spots, right? So for every point on the ACT, my model is increasing by 0.04 grade points, right? That's what's happening there. And then number 6 says, what is the y-intercept of the regression line, right? So the y-intercept of the regression line is 2.11, right? So we want to interpret this using real-world terms also, right? So we could say students that have a score of 0 on the ACT have an average freshman GPA. So I have an average freshman GPA of 2.11 in college, right? So that's an interpretation, right? So my x value is 0 and I have a y-intercept, and my y variable is the average GPA, right? So then another thing that I would note, so I would say note that a score of 0 on the ACT is not possible. The score range for the ACT is 1 to 36, right? So I did a quick Google search and found that on the ACT, the score range is always in between 1 and 36. So it's not possible to actually get a score of 0. So we did interpret the y-intercept, but it's just important to note that that's not actually practical, right? So it's not a practical answer, right, in the context of our problem, right? So then now we're asked to calculate the correlation coefficient. So we do this using the command COR, and then we can type in the variables. So I can do GPA, comma, ACT, and then hit enter. And notice, you know, the correlation doesn't change if I swap my x and y variables, right? And that's also true in R, right? If I swap those, if I put GPA first or second, I still get the same correlation, right? Correlation coefficient. So we could say the correlation coefficient, and then I would just say R click out of that. So the correlation coefficient R is 0.269, right? If I round that to 3 decimal places. So then next we're asked to describe the data. So we should discuss, one, is it linear or nonlinear? Do we have a perfect, strong, or weak correlation? And is it positive or negative, right? So a diagram that I shared with my students that I want to show you is the following. All right, so I'm going to make this full screen here so you can see this a little better. So here's a diagram that I picked up that just has an interpretation of R values, right? Correlation coefficient. So an R value of 1 is a perfect positive linear correlation, where an R value of 0.9 is you could say a strong positive linear correlation, and then something like 0.4 is a weak positive linear correlation, right? Then we have this also for negative correlations, right? So we can say perfect, strong, weak, and then an R value of 0, remember, it means no linear correlation, right? So these are just some helpful guidelines that you can use when describing a data set, right? So we have an R value of 0.269, so that's less than the 0.4. So we would actually say that's a weak, right? So when we describe this, so describe the data, this is probably what I would say here, right? So we could say like the scatter plot shows a weak, or maybe even, I don't know, a very weak positive linear correlation with, and then I'm going to do my insert equation, R equals 0.269, right? So that's probably something I would say there, right? So notice, is it linear or nonlinear? I did say is a linear correlation. Do we have a perfect, strong, or weak? I did talk about that, right? And then positive or negative, I identified that, right? So those are the 3 things that you should be describing in the data, right? And if we look at the scatter plot, right, it is a little bit of a stretch to say this is linear correlated, right? So I decided to proceed, right, so we can see some things, but there really doesn't seem to be a strong linear model here at all, right? So it makes sense to get an R value of 0.269, right? A very small R value. So then next it says, use your model to predict the average freshman GPA of students that scored a 36 on the ACT. So what I would do to show this is just come up here and go ahead and just copy our nice equation that we had written, right? And then just come in here and paste it. And then I'm replacing ACT with 36, right? So I can just hit 36 and then hit equals, and then we can type in that value, right? And you can actually use R as a calculator, right? So I can type this in 0.04 times 36 plus 2.11, and if I hit enter, I get an average GPA of 3.55, right? Oops. Right? So I used R as my calculator there, right? So then now number 10 says, is it reasonable to use our model for the prediction in question number 9? Why or why not, right? So what I can do in R is I can use the summary command and just type in data. And by doing so, we get some characteristics about each variable, right? So I'm worried about the x variable, right, the ACT. So my minimum value is 14 and my max is 35. So using my equation to pick a ACT value of 36 is greater than my maximum, right? Which means we have extrapolation, right? So we have to consider that in mind, right? So how I would respond to this is no, right? So no, our maximum ACT score in our data set is 35. Using our model to predict the score of 36 is extrapolation and could predict unrealistic results, right? We do not know if our data continues, right? Whoops, I had a typo here. So we do not know if our data continues in a linear fashion, and we could receive unrealistic results, right? So those are two key points to always keep in mind with extrapolation, right? But we can also note that our data set already has a weak linear correlation, right? So it really doesn't make sense to make the prediction, even though it's extrapolation, because my data set isn't even very strong linear, right? So even doing interpolation, even picking picking a ACT value in between my min and my max, so maybe like ACT of 20, that might not even have a lot of accuracy either, right? Because my R value is only 0.269, right? So then number 11 says superimpose a scatter plot with the regression line. Make the regression line red, right? So notice that I already have, if you remember, I already have my scatter plot and I didn't exit out of it. I just minimized it, right? So I have that back. So if I already have my scatter plot built, right, and if I want to add the regression line to it, what we do is we use the AB line command, right? So you're going to type in AB line and then open up parentheses and then type in model, right? Because that's what we named my model above. That's what I want to graph. And then I hit comma and then COL equals, and then in quotes I type in red, right? And that's telling to make my line red. So if I hit enter and then I look back at my scatter plot, it already added that on there for me, right? So I can right click on that, copy as a meta file, and then I can add that scatter plot in here, right? So I'm gonna knock number 11 down on the next page, so that way it looks nice and neat, right? We can center it. You can make it a little smaller if you want, right? So we have that nice scatter plot there, right? And then we're ready for the last question, and that is to calculate the coefficient of determination, right? So I'm done with this scatter plot now, so I'm going to go ahead and just exit out of it. So what we need, remember, the coefficient determination is just the correlation squared, right? R squared. So if I push the up arrow, I can hit previous commands, and this is the command that I need, this COR ACT comma GPA, right? So if you don't like hitting the up arrow, you can certainly retype that. But what we need to do is put it inside a parentheses, and then hit the shift 6, right, to get the caret, and then 2, right? So I'm taking that command and squaring it. If I hit enter, now I have R squared, right? So I'm going to hit Alt equals to bring my equation in, and if I go to script in this guy, this will do a superscript. So I can type in R and then click here and hit squared, then hit the right arrow to be back down, and I can hit equals. So my R squared value is 0.07, we'll say 2, or no, it would round to 3, 0.073, right? So there's my coefficient of determination. So I can say that 7.3% of variation in freshman college GPA is explained by ACT scores, right? So only 7.3% of the variation is explained, which means that we have, what, 92.7% unexplained. So that's really not good, right? That's a very very poor model, right? So this is a very poor model. In practice, you know, you really wouldn't want to use a linear model off of this data, right? Because it's not really linear correlated. But I thought this was a good data set and give you some good practice. So these are actual data points, right? This is real data, not just something I made up. And I walked you through the motions on how to complete our assignment number 2. So the R assignment number 2 that you're looking at, right? So if we go to R assignment number 2, so you're looking at a data set, crime, right? So if you click here, you can open up the assignment file, right? So I'll just save that to my downloads. Let that open up. Right? So what you're looking at is a criminologist is studying the relationship between the level of education and crime rate in medium-sized U.S. counties. Collected the following data for a random sample of 84 counties. Right? So you're looking at some data to see if there's a relationship between a level of education and crime rate, right? So I describe what each variable is, which is the x, which is the y, and what the variable represents, right? So this will be a very similar assignment. So I think that you'll find it's not very difficult, right? But you just want to make sure that you're putting things in context, writing full sentences, and interpreting things correctly. All right.